In this video, we're going to perform a hypothesis test for two standard deviations using the F distribution. A broth used to manufacture a pharmaceutical product has its sugar content in milligrams per milliliter measured several times on each of 3 successive days. Can you conclude that the variability of the process is lesser on the first day than on the second day? Let sigma sub 1 denote the variability of sugar content on the first day and sigma sub 2 denote the variability of sugar content on the second day. Use the alpha equals 0.10 level and the critical value method with the table. We're given our distribution. We're going to compare day 1 and day 2. So we need to create our hypotheses. The null hypothesis is a statement of equality, and in this case it's going to be sigma sub 1 is equal to sigma sub 2. Our alternate hypothesis is going to be based upon this statement: can you conclude that the variability of the process is lesser on the first day than on the second day? Therefore, sigma sub 1 less than sigma sub 2. Now, we're going to use the F distribution here, but there are a couple of things that we need to assume. First, that we have independent random samples from two populations, which we're going to say day 1 and day 2 are definitely independent, and that both populations are normal. Now, there's nowhere in the problem that states that we're assuming normality, but since we're using the F distribution, we will assume normality. Because the test for two standard deviations is extremely sensitive to the assumption of normality. And if the population differs even slightly off of a normal distribution, we shouldn't use this particular test. But that's what we're going to do in this particular problem. Now, what I'm going to recommend first is to go ahead and calculate your F statistic before going ahead and finding the critical value in the table. Reason being is that sometimes when you are doing a problem like this, you don't have the same number of data values in each of the populations. But in both of these, there are 10 data values. So it really isn't going to matter, because we're going to use degrees of freedom. And in this case, degrees of freedom is going to be equal to 10 minus 1 is going to be equal to 9, and that's for both of these. Now, when we go ahead and we calculate the F statistic, that's going to be equal to the greater or larger of the sample variances. Over the lesser or smaller of the sample variances. Okay, so let's go ahead and find our variances. I'm going to use technology, and I'm just going to simply use Excel because it's pretty easy to do. And so I bring in my Excel spreadsheet, and you'll notice that I've already populated the spreadsheet with the data values from day 1, 2, and 3. So the first thing that I want to do is go ahead and create the sample variance, or calculate the sample variance for day 1. I'm going to go ahead, type the equal sign, and then I'm going to type VAR for variance, and you'll notice that it gives me a drop-down menu. And I'm going to double-click variance for the population, and then I'm going to left-click and hold in this first cell of data, and I'm going to drag down to the last cell of data and let go. And then I'm going to press enter, and that calculates my variance for me. Now, I could do that again for day 2 and day 3, but I don't need to, because I'll put the crosshairs on this little green square, and I will drag it across those two cells, and it automatically calculates the variances for me. So we'll note that this first variance is smaller than this second variance. So that means 0.1421 will go in the numerator and 0.0205 will go in the denominator. So let's go ahead and calculate that. Now I can just go ahead and punch this into my calculator, but I'm going to go ahead and use Excel to do that for me. And so let's bring that back in. And so I'm just going to click in this cell right here. We'll type equals. I want to divide the greater value by the lesser value. Press enter and I get 6.93. We're going to round to 2 decimal places. So that means that my F statistic is 6.93. Now, let's go ahead and find our critical value. The critical value is going to be little f at significance 0.10, degrees of freedom for the numerator and the denominator. And we're going to use the table, the F distribution table, and there are so many different variations on that, depending on the textbook that you're using or depending upon the website that you copy it from. So what we want to do is go ahead and make sure that we are on the same page as far as what table we're using, and I'll be using the table from Elementary Statistics 3rd edition by William Navidi. And I've already gone ahead and copied a little portion of the table so that we can go ahead and we can determine what our critical value is. So let me scroll up a little bit. Let's look at this. And notice that there's a column that says denominator degrees of freedom, and there is a row that says numerator degrees of freedom. Now, what we're going to be looking for is to start with area. And since we are looking at a significance level of 0.100, that's where we're going to start. So denominator degrees of freedom is going to be 9, and so I'll be looking at this. And then numerator degrees of freedom is also 9, so I'll be looking at this. And where the row and the column intersect, I get 2.44. And now we are going to compare the F statistic to the critical value. And since big F is equal to 6.93 and little f is equal to 2.44, I note that big F is greater than little f at the significance level of 0.10. And therefore, and I'm going to use the mathematical symbol for therefore, we reject the null hypothesis. And that's at alpha equals 0.10. So what does that mean? What is our conclusion? Basically, there is enough evidence to conclude that the variability of the process is lesser on the first day than the second day.